So a humane society wanted to estimate with 95% confidence the proportion of households in its country that own at least one dog. Interpret the 95% confidence level in its context is going to be part A. And so when we do that, we go, okay, in repeated sampling, because they're saying confidence level, and when we're talking about the confidence level, they're not saying they're not asking you to interpret the confidence interval, just the level. So in repeated sampling, we would expect that on average, our method would capture the true population proportion that own at least one dog 95% of the time. The next part, the Humane Society selected a random sample of households in its county and used the sample to estimate the proportion of all households that own at least one dog. The conditions for calculations a 95% confidence interval for the proportion of households in this county that own at least dog were checked and verified. All right, so that means we don't have to run them. And the resulting interval was 0.417 plus 0.119. A National Pet Association claimed that 39% of all American households owned at least one dog. Does the Humane Society's interval provide evidence that the proportion of dog owners in this country is different from that of the national proportion? Well, that's a good question. So what does this really mean? Well, this means I can add 0.119 and find an upper bound and subtract 0.119 and get a lower bound. So 0.4117 minus 0.119 gives me my lower bound, and this is my upper bound. So if I was writing my interval, I'd go 0.298 and 0.536. There's my lower and my upper. Now, please remember, the nation is claiming 39%. So what am I? I'm 95% confident the true population lies within this interval. And I noticed that 0.39 lies within the interval. So I can't say that there's a difference. So at 95%, I cannot say that there's different than the Humane Society claim of 0.39. The next thing is how many households were selected in the Humane Society sample. Well, there's a couple ways to do this. I don't generally subscribe to this. I usually work it this way because I like the algebra side. And I know that this was my margin of error. All right. So p hat was given to us. Now, if they don't give it to us, you have to use 0.15, but they told us p hat was 0.417 up above. That's why we had the p hat is 0.417 plus or minus right here. All right. We also have a margin of error. They told us the margin of error was equal to 0.119. So that was given to us. So I plug in the values that I have, and I do a second VAR's inverse norm, and I get 1.96. I divide them, I square it, and then I divide that into whatever that ends up being. And I get 65.95. So let's try this out. So 0.417 times parenthesis 1 minus 0.417. That's where the 0.24311. Second VAR's inverse norm, 1 minus 0.95. That gives me my 1.96. We had a margin of error of 0.119. I divide it by this. And then I square that result. And then I go back up here and divide it by that little number. And there's our 65.948. We always round up. So this is going to round up to 66. If this had been 65.01, I still have to round up to 66. Always got to round up on that problem. Okay, some of you need to practice some algebra, but almost assured that they'll have this either on the multiple choice or on the free response or both.